Hi, everybody, and thank you for joining us today for the Data Architecture Virtual Group. Today, we're pleased to have Rahn presenting to us on realizing the full value of data warehousing in the cloud. My name is Kenny Neal, and I'm the co-chapter leader with Rob. Go through these past slides real quick. Anybody that wishes to submit a session for the 2018 PASS Summit, your deadline is today at 2300 UTC. It's about 2300 local time. On the 27th, PASS is going to have a Facebook Live event with Kendra Little, where she's going to be answering your questions. That's going to be really neat. Some upcoming virtual group webinars right here on this screen. That's what's left for the month of March and the beginning of April. And then we are one of several virtual groups. There's one for about every major platform and every major language, so I'm sure you'll find something interesting if you go look at the virtual groups. Upcoming SQL Saturdays for the rest of March and beginning of April. And out of a little point of pride here, I've added Baton Rouge, August 11th. Come join us if you're in the area. And lastly, we are part of the PASS organization. If you're not a member, please go to pass.org and sign up, and you can get on email lists for all the virtual groups and any of the local events. So with that, I'll go ahead and introduce Greg. Rahn is a Director of Product Management at Cloudera, where he is responsible for driving SQL Server product strategy as part of Cloudera's analytic database product, including working directly with Impala. Over his 20-year career, Greg has worked with relational database systems in a variety of roles, including software engineering, database administration, database performance engineering, and most recently, product management, which provides a holistic view and expertise on the database market. Previously, Greg was part of the esteemed real-world performance group at Oracle and was the first member of the product management team at Snowflake Compute. So with that, I'll go ahead and throw it over to Greg. There we go. Take it away, Greg.
All right, thanks, Ken. Just flip my presentation. All right, there we go. So hello, everyone. As Ken mentioned, my name is Rahn, and today we're going to talk around being able to realize the full value of data warehousing in the cloud. So just to kind of quickly jump in, there are a number of different drivers out there for organizations and motivations in terms of moving to the cloud. And a recent TDWI survey of a number of respondents found that scalability and flexibility were the two largest drivers for organizations to move to the cloud. When these folks were asked around the cloud and their motivations for it, they said that really the most attractive thing to them was the ability to scale on demand and the flexibility and the simplicity that cloud offered, right? So these two things were kind of key. But not far behind that was an interesting thing that I found, and that is the speed of getting things done, that is, was also a top driving factor. A lot of folks found that they could move faster and more agilely if they were in the cloud and do so with less IT involvement. And generally, respondents commented that they found implementations in the cloud generally were done in less time than the ones that they had done with their traditional data center deployments. And they attributed this to, again, the increased agility and the ability to iterate faster. Unsurprisingly, cost was another driver for response of this TWI survey. Although some folks say there are potential hidden costs associated with cloud, most organizations feel that the faster time to do implementations and iterate quickly allow them to reduce.
Excuse me, Greg. I don't know if it's just me, but your audio is kind of cutting out.
Okay. I don't, it's just my internet, I guess, but I don't have anything specific there. I'll try to speak a little slower. That cost was another driver, and that the ability to do things quickly and iterate was a big factor when moving analytics to the cloud. So it's probably no surprise what was found in this survey. But when we kind of look at the common types of cloud workloads, we see that there's kind of two main areas that folks operate in terms of analytics, right? There's kind of the data preparation or traditional ETL or ELT, and also there is the reporting side or the publication side and access to that data through business intelligence and SQL queries, right? The interesting thing with these two workloads is they can both leverage very different aspects of the cloud. For ETL or data preparation, which is generally job or pipeline driven and very transient in nature, one can leverage job or pipeline based clusters and size them based on their SLA times to get a big cost advantage, right? This also means because they are deploying these jobs or these pipelines in separate compute from their business intelligence, that there's no contention between the two. And yet with a shared object store underneath both of them, there's no data silos either. They both have access to the same data sets. On the SQL and BI side, typically clusters are a little bit more longer running, and they provide the means to kind of access and query the data, so no surprise there. But the big thing here is that they can tap into advantages of cloud by running over this shared object store. And as kind of mentioned, this means that you can scale BI and ETL jobs independently, and in addition, you can have multiple reporting or SQL clusters over the same data set and size and scale those independently. So it really gives a big advantage from a topology standpoint, from a resource isolation and a scalability angle. So the one thing that is notable, though, is that without kind of having a shared metadata layer between the data storage, if you will, and the compute, you're in essence just kind of creating more data silos in the cloud. And that's obviously something that we really would want to avoid. So what are kind of the key things driving more workloads for analytics to the cloud? So first and foremost, the ability to cost effectively store large amounts of data in a single shared repository in a cloud object store is really becoming the foundational element for a lot of data warehouse use cases in the cloud, right? The ability for S3 and Amazon or Azure Data Lake Store to contain large amounts of data and scale that out and pay for only what you need is a really big driver here. Next, you are able to access, in essence, limitless utility-based compute to power your applications, right? So because in the cloud you have the separation of compute and storage, if you will, you can scale these two things independently. And in this sense too, we both are kind of, for both of these, we're on a pay-as-we-use basis. We don't need to pay ahead of time, and we can adjust our workloads and size them accordingly so that they can control costs and expenditures. And then kind of lastly, on the processing and data storage side, we've had open and modular formats and engines. For example, Apache Spark and Apache Impala are both processing engines, and Apache Parquet is an analytical file format that both of these engines support today. So really, if you kind of look at this, we have kind of a 1-2-3 punch in terms of technologies that can constitute a data warehousing use case and leverage the attributes for cloud. So when you're moving to the cloud, you of course are looking first and foremost for that high-performance SQL that you are used to from your on-premises systems, but there increasingly are more and more attributes, if you will, that are becoming important and more important to organizations. In terms of data flexibility, one really wants to have the ability to bring in any type of data, if you will, and not be limited to certain formats, and operate on that data and model it kind of in place. The old days, people used to kind of bring in data on a laptop and build rigid schemas and then load those schemas. And in today's world, there are so many different data sources that having the ability to bring that data in whatever format and operate it kind of in situ is becoming more and more important. Also, in terms of storing data for analytics, we really are looking at the ability to have an open format that supports many different engines, so that if we decide that we want to change engines or move or adopt something new, that we don't have to convert large amounts of data. Right? Data has immense gravity these days, and more people are collecting data, so it's becoming more and more important that we don't have any storage lock-ins. SQL has always been the go-to language for analytics, but more and more use cases are coming up that for things like data or machine learning and these types of workloads, that we want to be able to support more than just SQL itself. And that's where it becomes important to have these open data formats on a shared data platform, because SQL is great, but it's not the only solution that enterprises need to support today. And then, of course, we want to be able to scale effectively and under a reasonable cost, right? Because the cloud allows us to have elastic clusters and scale out on a node-by-node basis. We don't need to think about things like forklift upgrades anymore. We can also upgrade kind of in place, and by that I mean we can deploy a new service, move things to it, and then retire the old service if we want to upgrade something in place, so to speak. So, and additionally, there are numbers of different organizations running at cloud at quite large scale, over hundreds of terabytes or even petabytes of data. And then lastly, we want to be able to run our workloads both on cloud and on premises, because it's unlikely that most organizations can make a binary cutover, right? So we have to plan for this and understand what that means. And so being able to have an on-premises solution that matches the cloud solution leads for a easier transition, including different storage options like S3, ADLS, HDFS, if you will, Kudu, Isilon, etc. Okay, so now that we've discussed some of the technology options that are behind the move to run BI in the cloud and other modern analytics systems, one has to kind of ask themselves, what are the considerations organizations should think about if they want to move their workloads to the cloud? So if you think around how most on-premises analytics are deployed, or think around your traditional database, if you will, there's kind of like this monolithic topology where all the components, if you will, the processes are within one box, and that includes, for example, from a database perspective, like the query engine itself and the storage engine, right? So all databases kind of own storage, if you will. You can't kind of query across storage from different formats, because each one has its own proprietary base storage. And if you're moving to a big data platform, generally what that kind of looks like is that you have a single shared storage layer, and you have a number of different tenants that may use different processing engines, etc., on top of that data, but it's all kind of on the same cluster. So generally, on-premises clusters share workloads, and they have multiple tenants in that sense. So in the cloud, this paradigm changes a little bit, right? So what we are able to do is we can share the data under this kind of object store that is visible to all compute instances in the cloud. And what we can do then is, instead of having one cluster where we have all these different applications running on it, kind of time sharing, we can right size each one kind of individually, right? So we can take our ETL jobs and size them appropriately, and then we can have one or more database clusters and size them each individually too, and then let them share a single object store of data. So this is kind of key, and one of the big and most interesting things to me in the cloud is that we, in essence, can separate these two things and scale them out independently and support many different applications. So when it comes to data warehousing in the cloud, there's typically, I tell people, 3 different architectures that one can deploy. And they're for various different use cases. There's more of a transient in nature use case, where there's kind of job or infrequent usage. There's kind of longer running over shared data use case. And then there's also kind of persistent long running clusters with local storage. And this is another use case that is based for high performance stuff. And kind of the Goldilocks, if you will, the just right choice of these 3, I would say, and what I steer people toward, is kind of the long running with cluster-based or cloud-based storage. And I'll dive into each one of these and go through kind of the advantage of them in a little bit more detail. So if we take a look at kind of the default choice here, if you will, of longer running BI over an object store, the big thing here is that this type of deployment and topology is really best for both elasticity and kind of speed, if you will, or rather best elasticity versus speed, or being specifically transient, right? So when we want to grow and shrink clusters, if they have local storage, that data needs to be redistributed to other nodes, right? We can't just turn off a node in a cluster if it has local storage. With an object store, all the data storage is remote, if you will. So for compute-only clusters, we can turn off nodes very easily, and we can add nodes very easily. So it's very flexible in that sense. If you consider most workloads in terms of BI, if you will, generally there are busier parts of the day, 9 to 5 versus, say, the weekend. And so in these cases, we can grow and shrink our clusters to accommodate just the right amount of processing and SLAs and not overpay for that compute, right? So this allows us to have kind of a multi-tenant support. We can give people self-service access to such a things. It's optimized for kind of grow and shrink and cost efficiency, that it's rather quick to grow or shrink, and that we only pay for what we use there. And as our workload scales up, we can incrementally add more compute to our clusters, or we can deploy new clusters that operate over this same shared object store and scale those out independently as well. Next on the list, I have persistent BI with locally attached storage. So this is generally the best option when there are really tight SLAs for performance, right? So in this case, we're most likely operating on local SSD-based storage versus a remote object store, if you will. And this also gives the advantage, if you will, of kind of both the previous version and local storage, because they're not mutually exclusive. In this case, a cluster with local storage can have data there, and obviously if it's local, it can't be shared to other clusters, if you will, but it can operate also over that shared object store underneath it that other clusters are accessing. So if there's a certain data set or a certain set of reports that need tighter SLAs, we can kind of elevate that to local storage to reduce our SLA times, or integrate, if you will, with other storage engines that are not supported on an object store like Apache Kudu, which is a mutable data store, if you will. So this also gives us the ability to grow and shrink our clusters, but because we have local data, we can never shrink them smaller than the local data allows us to. So there's some restriction there, but growing the other direction, we can add nodes incrementally, but there is time to do data redistribution and for the data to be re-replicated. So there's a little bit more lag, and it's a little bit more kind of costly in terms of resources, because obviously data distribution takes some time and resources. And this isn't something that you would kind of size up, size down several times a day. It would be more that you would deploy a cluster, and as your workload increases, you could add a node, maybe once a week or however you need to based on your requirements. So the third type of cluster topology that we have in our discussion today is really more around transient workloads, be it either for business intelligence or SQL or ETL or data pipelines over that shared object store. And this really is the best option when you have things that are scheduled, like ETL pipelines or data pipelines that you can run. You can isolate them from other workloads, operate over that shared data store, and then turn them off. So they only are accruing a cost when you're actually using them. Similarly, from kind of the query or publication side, if you will, if you have a use case that warrants a pop-up data mart, as I refer to it, this type of topology lets you deploy rather quickly because you're only deploying compute. And then you can run your workloads on there. So maybe you have a team of data scientists running or investigating a new data set. It might make sense to use more of a transient cluster where you pop it up during the day. They take a look at it during the business day. They figure out what they're going to do with it. Maybe they do a little modeling and understand what the next steps are. And then when they leave, they turn it off. And they were able to do all this without impacting kind of your high value production reports, right? So it really opens up a lot of flexibility in an organization in terms of allowing people access to things. Traditionally with kind of the fixed on-premises model, most things run pretty close to 100% utilization. So when any new use case in, it means that somebody has to yield or slow down for somebody else. This kind of lets folks run at kind of full speed independently, albeit for a small cost. So now that we've kind of discussed the different topologies and options for deploying analytics in the cloud, I wanted to discuss kind of a major advantage that this architecture brings to an organization, and that's something that is kind of referred to generally as the logical data warehouse. So Gartner had a publication entitled "Solve Your Data Management Changes with the Data Management Infrastructure Model" last year, and they kind of quadrant off kind of how folks work with data, if you will. They typically have kind of groups of data. You have kind of like your known data and your unknown or yet to be explored data. And then of course on the questions of asking of that data, you also have both a known and unknown category. And so they kind of map this out into these 4 quadrants, and they kind of overlap in this type of sense, in that the life cycle, if you will, of analytics and understanding data generally starts with exploration and discovery, right? These are the folks who are, probably a couple people on a team looking at a new data set. Then they determine that there's actually something valuable in this data set. So it proceeds down to the lower right-hand quadrant. Maybe there's a few more people that get involved there. And then in essence, it runs over to the left and becomes kind of a foundational element in your logical data warehouse, right? So this is where your core reports are being done. Folks are running kind of the standardized dashboards over it because we have kind of now both a known data set and a known set of questions, right? And sometimes we actually tilt upward back into the unknown business questions, saying, well, we have a known data set that's well curated and out there, and people are asking themselves, are there more questions that I can ask of this data, and what else could I do with it, right? So the ease of deployment that cloud offers you, combined with the ability to have that single shared data set under discrete clusters, really enables this type of workflow for different teams across different groups in an organization. So really what we're looking at here is a logical data warehouse, if you will, that looks similar to this, right? So we have kind of that, on the bottom, we have a global single shared storage layer where we leverage S3 or ADLS and the object store, which is of course visible to all compute. And then over that, we layer a very important piece of this, that is the shared metadata security and governance, right? So since we kind of broke apart, if you will, the tight coupling of legacy systems into a more modular, we still have very important elements of that we want to share, both the data and the metadata, if you will, so that there's a single source of truth and definitions, if you will. And then on top of that, you have many, many different types of workloads and use cases that you can run on there. Like, so for here, to kind of map back to the previous slide, we have kind of a discovery cluster. We can have exploration clusters on more curated data. We can be doing data preparation on a data engineering cluster, and move even toward things like data science, where we're building out and testing new models. And then of course, we have our standard regular and dashboards of reporting, right? So this is kind of a topology that lets you support all the skills, all at their kind of own pace and growth, without kind of any restriction, right? And I think this is really how organizations really derive the most value from their data and become a much more data-driven company, right? If people are fighting to get access to things or having challenges or friction, it is very frustrating for folks in the data world, as many of you may be able to relate to. So I think cloud really opens things up there, and yet we open things up, but we still curate it in terms of security, governance, and metadata. So when you're out there kind of shopping for platforms or considering new topologies in the cloud, what are kind of the critical questions one should be asking of themselves, and kind of looking and diving into different platforms and what they offer? And so I think there's a number of different areas here, and we kind of relate back to the areas that I had on a previous slide in terms of flexibility and scale, operating beyond SQL, and operating over multiple environments. And some of those questions really kind of help you guide, are meant to help you guide in evaluation, right? They're, in terms of flexibility, one of the key questions that I tell people is does a system actually need you to copy data into the database, right? So many times we get cloud deployed software, but in essence, it's another silo. So the data must move from its current location, possibly in a cloud object store, into a cluster on local storage, and now it's no longer shared, right? So that's kind of a challenge there. Again, in terms of flexibility, do you need to have upfront modeling or a proprietary data format? Like when you process your data, is the output of it a format that is optimal for analytics and supported across a number of different analytical engines, such that you don't have to reload or recopy or convert different data into more formats and end up paying more storage costs for that data? In terms of scaling, one of the key things here is that you can scale both your compute and your storage independently, right? This is the key attribute to cloud, and really what allows folks to right size or just in time size their clusters and their data, right? The days of buying terabytes or hundreds of terabytes of storage because you had to do this every year, every 3 years is done, right? You literally just drop data into a object store, and you only need to pay for what you actually use. There's no sizing, no forecasting, no nothing in that anymore, right? And so relatedly, when you're growing and shrinking your cluster, what's involved? Sometimes things can be resized, but is it require actually a little bit of data movement behind the curtain, so to speak, right? A lot of times on-premises software is deployed in the cloud, and they have options to move or resize things, but really what that means is, they provision a new version of the cluster and put your original cluster in read-only mode and then copy that data over to it. So technically you get a logical resize, but it requires physically moving data. And then again, in terms of SQL and non-SQL access, do you have the ability to share data easily across different workloads for both SQL and non-SQL? Or do you actually have to move data into another system and require kind of yet another data silo? In terms of storage and flexibility in the hybrid world, do the different offerings allow you to natively store data in an object store? And does that system also allow you to span from on-premises into the cloud, or even support more than one cloud environment, right? So it's kind of useful if you have the same topology kind of wherever you deploy, whether it be in your data center, in Azure, or in AWS, having that same experience is really kind of a key feature. So with that, I would love to dive into a couple of case studies to tell you how some customers are out there solving their data challenges today. So first, I'll introduce Cox Automotive. So just a little background on Cox. They're a automotive company and a leading provider of products and services for both automotive dealers and car buyers. So there's a number of different brands, if you will, under Cox, some that I'm sure many will recognize, including names like Auto Trader, Kelley Blue Book, and Next Gear Capital. And all these different companies are working kind of together to transform the way that people buy and sell cars. So each of the company's brands address different segments of the automotive buying lifecycle, whether it be from manufacturing or distribution or ownership or reselling, and ultimately to retirement and end of life, if you will. So their use case is around a mature environment that they had, and really were looking to try and bring in the benefits across a larger, newly formed holistic company across all the brands. So this team had been able to cut or reduce its storage costs in half, if you will, in terms of the cost per terabyte, and then really expand and make much greater use of its different data sources. One such example is being able to show the real-time customer responsiveness to Super Bowl ads on its websites and its advertisements with press, and highlighting really their industry relevance and experience. Another early benefit of combining these companies is that their data is now with their data, they have the ability to assess auto supply and demand in specific markets and target their price accordingly, right? So they can kind of really optimize their offerings based on price and demand, and that's something that's really completely very data-driven. So next on the list of customers that I'd highlight is Komatsu. So a little background on Komatsu. They were formerly known as Joy Global, and they are a global mining and equipment and services provider that specialize in solutions for the excavation of energy, industrial, and hard rock minerals. So their use case is around committing to helping its customers improve the safety, productivity, and the cost of their different mining operations. So they have a offering that is called an Industrial Internet of Things, or IIoT, and they have this service, which the name of it is called Joy Smart Solutions. And that offering allows their customers to optimize their machine performance by using real-time data and analytics attained from these smart connected devices and assets. These devices and assets and this application include some of the largest mobile mining equipment used in surface and underground mining. Things like long wall mining systems, electric mining shovels, continuous miners, wheel loaders, among others. So these are some very large equipment, the kind that probably your 7-year-old boys get excited around when they get one for Christmas, right? So these are the biggest of the big things. These are not tiny Internet of Things. So with their unified data management platform, JoySmart teams can now more easily analyze data from the company's brands and mining machines, as well as from different third-party programmatic logic controllers and equipment. So they're getting actually third-party data in here as well. And this gives them a very holistic systems view of all the mining operations that are going on. Then the company's data scientists can help produce different machine learning models over this data to provide results faster than was previously possible. So understanding all the movement of their different trucks and things like this in the mines are studied, collected, and analyzed, and then data scientists are really optimizing over all this data to provide them the right routes to take, if they should stop, when they have to do maintenance, and things like this. So the big picture here allows them to understand kind of their machine health and operations, and lets all their teams partner with their customers to help improve ways to have more equipment safety, productivity, and reducing their operating costs. So again, really just a big platform of collecting many small points of data, analyzing them, optimizing them, studying them, and being able to increase their productivity and reduce their costs, all from a data-driven platform. So with that, we'll just kind of go over what Cloudera Enterprise, which is the modern platform for machine learning and analytics optimized for the cloud, entails. So as we kind of talk through a number of different points in the session so far, on the bottom we have a number of different storage service options, be it in the cloud, in Amazon, AWS, in Azure, HDFS, or Kudu. And those all tie into what we call the shared data experience, which is that common layer of security, governance, data catalog, workload management, etc. And then on top of that, you run all these different core services for the different workloads that are out there, including data science, analytic database, operational database, data engineering, or whatever extensible application that you would like to run on the platform as well. So with that, I just would like to highlight just one more thing, and that is that when you have a diverse set of workloads, you don't necessarily have to have a diverse set of storage models. Like, you can bring these all in. And that's really what I would say is the key benefit to such a platform, is that having one platform across different data centers and clouds, all with kind of the same user experience, supporting a number of different applications. So no matter where you're storing your data, where you're operating it on, you can have kind of that common way of seeing your data and have that common set of services across it. So with that, I would like to say thank you and take questions from the audience if there are any.
Thank you, Greg. We do have one question. What are you using as the shared metadata repository, and can you make a recommendation?
Yeah, so the shared metadata repository is kind of a few things, if you will. It's not kind of just one thing. So in this previous diagram, where we have, let me just bring it back up here, kind of the shared data experience layer, these are kind of logically the the categories of data that are organized. But in terms of the metadata and how this all works, there's a number of different modular systems supporting all these. So in terms of data catalog, the open source Hive Metastore catalog, which is kind of less tied to Hive these days, stores kind of the data dictionary, if you will, of all the tables, right? So these are your table names, your column names, types, and stuff like that. Security-wise, that is brought together through a project known as Sentry, and this contains essentially the RBAC, the access controls, the authorization, if you will, who can access what tables. So this is kind of, again, a more modular breakdown, if you will, of what you would see kind of in a traditional monolithic RDBMS, right? So you have things like authentication and data dictionary, and then you also have authorization and security, right? And then in terms of governance and workload management, these just kind of all tie in through Cloudera's Navigator product, which allows you to track lineage and access controls and audit, and that's kind of how it's all brought together. And so one other thing, I guess, does that kind of answer the question? Hopefully.
I think so.
If not, yeah. Okay. I guess lastly, I'd also highlight if you would like to find more information on kind of the Cloudera platform, you can go to cloudera.com/altus, ALTUS, and that talks a bit more and shows a bit more of what's out there today in terms of what's kind of behind this slide in terms of the software and the products, if you will, right? With an L, I should say. Oh. A little typo in your thing there.
Thank you very much.
Oh, I should say to all.
Are there any other questions? I don't see any more in the list. If anybody else has a question, go ahead and type them in. No, I guess not. Thank you very much, Greg.
Well, thanks a lot for having us today, Ken.
Appreciate it. Thank you, everybody, for joining us today. We'll see you again next time. Bye-bye.